Well, class, we are now in Chapter 11. And Chapter 11 is all about counting principles. And we're going to start with a very basic one, and that is fundamental counting principle. We're going to start first with a little example where we draw connections of choice and differences of choices. So let's read. Suppose you have 3 t-shirts. So we have t-shirts. Oops, let me get color on my pen. And you have 3 pairs of pants. Okay, now the t-shirts are blue, yellow, and red. And the pants are black, brown, and gray. So I've got this distribution table, and I have that with the blue t-shirt, I can either wear the black pants, the brown pants, or the gray pants and have a good outfit. So our outfits are t-shirts and pants. All right. So our first possibility of choice is blue for the t-shirt and black pants. Blue for the t-shirt and brown pants. Blue for the t-shirt and gray pants. Now we're going to the yellow t-shirt. So we can have yellow t-shirt and black pants. Or the yellow t-shirt with the brown pants. Or the yellow t-shirt with the gray. Well, the last t-shirts were the red. The red t-shirt with the black pants. The red t-shirt with the brown pants. And the red t-shirt with the gray pants. All right. Well, how many different outfits can we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, I counted wrong. 3, 6, 9. So we have 9 distinct outfits with 3 t-shirts and 3 pants. Well, we notice that if we multiply the set of colored t-shirts times the pants, we come up with that number. And what we've demonstrated is a fundamental counting principle. So let's look into that. So there are 9 ways to pair shirts and pants to make an outfit. And this is fundamental counting principle. It says, if you can choose one item from a group of M items and a second item from the group of N items, then the total number of 2 items is M times N. So what it means for me is that if we know how many cardinality of set 1 time cardinality, talking about a distinctive quantity of 2 sets or more. It doesn't have to be just 2 sets. So we're going to do some examples. Here we go. I'm going to make this larger, and that way I can see and you can as well. A restaurant offers 10 appetizers. It's a very big one if it has 10 appetizers. Okay, and I'm writing awful. That's 1 set. 7 main courses. The second set. In how many ways can sorry about the typo, can a person order a 2-course meal? Well, that's the fundamental counting principle. So that is our M times N. Well, our M is appetizers, and we're going to multiply by our N, which is the main courses. So we can order 70 ways to choose from 10 appetizers and 7 main courses. All right. So let's do another example. Easy, easy. Remember, you need to have more than one countable set of items. An ice cream store sells 4 drinks in 4 sizes with 4 flavors. In how many ways can a customer order a drink? So we have 4 sizes of drinks. 4 drinks possible. Think of it like Coke, Diet Coke, Dr. Pepper, Diet Dr. Pepper, or tea and sweet or unsweet. Anyway, 4 of these drinks. And then we have 4 sizes, large, medium, and small, and 4 flavors that you can add. So 4 times 4, 16 times 4 is 64 ways to order a drink. All right, nothing hard, super duper easy. Well, this is what you usually see or have choices from. We have a main course, and it has ham, chicken, and fish, 3 of them. Vegetables, corn or green beans, 2. Beverages, only coffee, tea, or milk, 3 choices. Desserts, cake, pie, and sherbet. So that's 3 choices as well. If an item is taken from each of the 4 groups, in how many ways can a meal be ordered? So we have the 3 times the 2 times the 3 times the 3. Well, this is 6. Now we have 54 ways a meal can be ordered. There you have it. Again, you can have more. So long we know the quantity of items, we multiply them and we can arrive at the total fundamental counting principle. All right. Shoppers in a large shopping mall, and that's not male, it's a mall, are categorized as male, female, okay, over 30 or under 30, cash or credit card. In how many ways can a shopper be categorized? All right, so the items are the count for male, female is 2 choices. Greater than 30 or under 30 is 2 choices. Cash or credit is 2. So the numbers, this is the fundamental counting principle. Because you've got more than one set. So it is 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8 ways. Shopper can be categorized. Categorized. Put in a category. All right, nothing difficult. You are taking a multiple choice test that has 6 questions. Each question has 5 answer choices. With 1 correct answer per question. If you select one of these choices for each question and leave nothing blank, how many ways can you answer a question? All right, now think about it. So each one, there's 6 questions. Each one has 5 possible choices. One correct. So I've got 6 times 5. 30 ways to answer 6 questions. All right. That's why a multiple choice test is, I always think of it as a best guess. They always confuse me. Okay. A local 7-digit telephone number in a city, city A, have 58 as the first. Oh, and this is 58. I have a typo here, and I'm sorry about that. I wrote that down after I typed the information. Let me see what I wrote. 358. So, sorry, this is 358 as the first 3 digits. Those are set in this telephone, like an area code, as the first digit. How many different phone numbers are possible in city A? And I remember they have 7 digits. All right, well, let's talk about digits. Digits are what we create numbers. So there would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the digits. That's all we can use to make a number. So I could have 0000 as a phone number. Okay, that could happen in this type of a problem because they didn't give us any information about the fact that we couldn't use those digits. So each one of these is 10 possibilities. So that's a fundamental counting principle. So it is 10 times 10 times 10 times 10. So we are going to have 10,000 unique telephone numbers. All right. Now they give us one with license plates. And in these license plates, and we have them here, we have letters and we have numbers. So a license plate in a particular state has 4 letters and 2 numbers. And these are digits. So we know that the number of these guys is 10. And these guys are 26 letters. So we can have Z, 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 all of those. Z, A, Z, B, Z, C, any kind of combination we can have with those letters. So they're 26. So this means I would multiply. All right. So we're going to stick that in the calculator, that large number. And so let me get that. So we're going to have 26 4 times. So we're going to have 26 up caret 4 because it's repeated multiplication. And then we're going to multiply that by 10 squared. And we're going to enter. Of course, many, many. 4, 5, 6, 9, 7, 6, 0, 0. So I'm going to put commas, 45,697,600. That's a 0. All right. So there you have it. We are done with this section. And we've used fundamental counting principle. And this means we have what? That's right. At least 2 countable sets. Of items. So it is the quantity of the set M times N. It's what the formula said. Now I just write set times set. All right. So thank you very much for listening. Make sure you have a calculator and do the homework.